My name's Ashley Foreman, and this is Lab 2. The purpose of this lab was to remodel the previous lab on charged tapes, which set out to model the interaction between two charged pieces of tapes in order to find the amount of excess charge on one piece of the charged tape to have a more accurate model of our experiment. This time we modeled the tape's charges as equally dispersed line charges. The assumptions I made in this lab were that the charges were line charges, and so that each U-tape had evenly distributed charge along the length of the tape, and that the two charges had about the same amount of charge, and that there was no air resistance. And so in this model, we solve for the electric force, and we solve the magnitude of electric force and the magnitude of the gravitational force. And so the fundamental physics principles, Newton's third law, for every action there's an equal and opposite reaction, equal and opposite forces. Point charges, like charges repel, opposite charges attract. Newton's second law, force equals mass and acceleration. Superposition principles in electric fields, every charge creates an electric field independent of the presence of other charges. And Coulomb's law, force equals K, Q1, Q2 over R squared. And so the initial values in the system surroundings are all from Lab 1, and so the system is the charged tapes. Surroundings is everything else. The initial values, so the tape length is 0.2 meters, the tape width is 0.02 meters, the floating distance is 0.011 meters, the tape mass is 0.0002 kilograms, and the charge is 5.36 times 10 to the negative 9 coulombs. And so the main result of this lab, as you can see, there is a difference in the magnitude of the electrical force versus the gravitational force using the charge that we found in the last lab. And so the experiment versus the computational model. And so in Lab 1, the experiment, we created two pieces of charged U-tapes by ripping the L tape off another piece of base tape. And we determined the charge of the tape by holding a negatively charged object towards it and then found the amount of charge through measuring the separation distance of the tapes in order to cause one to float. And so in this new computational model for Lab 2, we entered the experimental data and made a multitude of assumptions. This allowed us to calculate the magnitude of electric force and the magnitude of the gravitational force. And so here's the code. This is just the data we used from Lab 1. This is the function for the electric field from Lab 0. This is the floating distance for the line charge. That's the 0.011 over 2 and the negative 0.011 over 2, and this is just to place the top tape and bottom tape. Here's the E scale, and so that was just what fit the model best and made it look correct. Here's calculating the electric force, which is the charge times the E field, and so that's through here. And then this is just the arrow scale for the electric force vector and then the gravitational force vector. And so the possible sources of error are mostly due to the assumptions that we made in modeling this experiment. And so, but there could have been parts of the experiment. So we could have had error in calculating the separation distance. Could have neglecting error resistance when there could have been some. We assumed the tapes were equally charged and they could have had different magnitudes of charge. And then the number of charges along the line is too small, and so that just means the amount of charges that is on the line. The accuracy of the model increases, the number of charges increases, so only having 10 versus 20 makes my model slightly more inaccurate. So what if I had modeled the tapes as a single point charge like in the previous lab, and then I compare this estimated value to the charge you get when you use experimental data to produce a point charge model to the value you go with your line charge model. So if I had modeled these tapes as a single point charge like in the previous lab, I would have gotten the same value as the previous lab for the charge of one tape. The value I get for the charge of one tape for this model is 4.70942 e to the negative 9, like 10 to the negative 9th, with the difference between the point charges model of 4.2653 e to the negative 10th. And so that was just with setting the magnitude of the gravitational force equal to the magnitude of the electric force and trying to find the charge. And so why do these estimates differ? And so which value is more likely to be closer to the real value and why? So these values differ so greatly as the gravitational force must be equal to for the electric force. And so in order to make these values equal and thus the net force 0, we must alter the charge of the tape. And so the more accurate model is likely the line charge model, as the tape is evenly dispersed with charge, which is how the tape in the experiment is dispersed. And that's all.